Hello class, today we are going to discuss another chapter, that is solution. So the first question is that what is a solution? A solution is called homogeneous mixture of two or more components. The mixture should be homogeneous. So homogeneous mixture is called solution. What do we understand by homogeneous mixtures? Homogeneous mixtures shows only one phase. Okay, suppose we added a pinch of salt in water and now we will dissolve it. After dissolution, we will see that we can see only water but not the salt present over there. So there is only one phase, that is called, that's why it is called homogeneous mixture, and such type of mixture are called solutions. This chapter is based on properties of dilute solutions. So here we will also see some of the properties of the solution. Okay, here we go. If we talk about solution, solution has two major parts that can be divided as, that can be called components of solution. Like solution has two main parts, first is solvent and second is solute. First is solvent and second is solute. Solvent is generally, not always, but generally considered as large proportion where solute is considered to be small proportion. In a solution, it is general consideration that solvent will be more and solute will be less in amount. Okay. And solvent, the specialty of the solvent, we can define the solvent, the component which is having large proportion, and we can also say that the solvent is having same phase as solution. Okay, same phase as solution, it means जिसका phase solution के phase जैसा है, that part will be called solvent. And there will be a number of types of different kind of solution depending upon the physical states of the solvent and the solute. Liquid solid solution, solid solid solution, gas liquid solution, liquid gas solution, etc., etc. But important is to discuss over here the part that is called concentration. This is the most important part of this chapter, concentration. What do we understand concentration? The concentration roughly categorized as concentrated solution, dilute solution. It means a solution which is containing more amount of the solute is called concentrated solution, and the solution which contains large amount of the solvent called dilute solution. But how do we define concentration? Concentration can be defined over here as amount of solute dissolved. Amount of solute dissolved. Okay. That how much amount of solute is dissolved in a solution or in a solvent, that is termed as concentration, and concentration has various types. Now we shall talk about the term concentration. As I told you, concentration refers to the amount of solute dissolved in a solvent or in a solution. So concentration is having various types, like it is percentage based, it is mole based, and it is gram equivalent based. These are the various ways to express the concentration of a solution. If we talk about percentage based, that is also known as percentage composition. A percentage composition, in this there is mass by mass percentage. Okay, then it is also called weight by weight. W means weight by weight. Then it's called mass, like another type is mass by volume percentage, M by V percentage. Second type, it is also known as weight by volume. Third type is volume by volume percentage. And fourth type is ppm, that refers to parts per million. Concentration in terms of percentage can be given as weight by weight percent. It means how much weight of solute is present in a given weight of the solvent. And mass by volume, it means how much weight of the solute is present in each 100 volume of solvent or solution, I say. And same, the volume by volume percentage means how much volume of solute is present in the given volume of a solvent or a solution. Parts per million, it means what amount of solute is present in each million part of a solvent. Basically, this type of percentage is part per million, that is used to refer a very trace amount. It means a very small amount of solute in a solution. Suppose that in a tank of water I added 2 milligrams or 3 milligrams of some solvent, some solute. So in that case it is called parts per million. Okay. In the mole based percentage, there are different type of percentages. First, in this kind, first is molarity. That one is molarity. Then second is called molality. Okay. Third one is here mole fraction. These are the three types of mole based percentage: molarity, and mole fraction. And gram equivalent based concentration is known as normality. Okay. It refers to the symbol capital M, small m, and it refers to the symbol chi. Normality refers to the symbol capital M. We will discuss in detail about these terms right now. Now we shall talk about percentage based composition. That is also known as percentage composition. Okay. So here we go. That was mass by mass percentage. A mass by mass percentage having a formula, that is mass of solute over mass of solution multiplied by 100. Okay. Because it's percentage, so we have to multiply by 100, and that's the mass of solute and this is the mass of solution. One important thing that you need to pay attention over here is mass of solution. Yes, here we must understand the mass of solution is equals to mass of solvent plus mass of solute. Okay. This mass of solution is a special thing to understand the mass of solvent plus mass of solute, because suppose that if I simply say to you that I dissolved 10 grams of sugar in 100 grams of water and what is the percentage of this solution, you will simply answer the percentage is 10%, because 10 grams is sugar and 100 grams of water. Yes, multiply by 100, answer is 10. No, answer is not 10. Because the formula says that mass of solution is equal to the mass of solvent plus mass of the solute. So in that case, the mass of solution will be 110 grams, because mass and mass both are the same units, and that's why they will be summed up. Mass plus volume cannot be added up, but mass plus mass is added up. So here you need to pay attention. Mass of the solution is always mass of solvent plus mass of solute. Okay. Next is mass by volume percentage. Mass by volume percentage. A mass by volume percentage means we are talking about mass of solute over volume of solution multiplied by 100. In this case, the volume of solution or the volume of solvent will be the same thing, because on dissolving a solid into liquid, volume doesn't change. Volume बदलता नहीं है, so in this case volume is unaffected. Moreover, mass cannot be added to volume. Volume can be added to volume, mass can be added to mass, but mass cannot be added to volume, and volume cannot be added to mass. So this is the formula for mass by volume percentage. And third one is volume by volume percentage. That is volume of solute over volume of solution. Multiplied by 100. Okay. So in this case we have come to know about the percentage composition. There is the formula of percentage compositions. Okay. Volume of solution. Volume of solution will be equal to the sum of volume of solvent plus volume of solute. This is the formulas of the percentage composition. So any volume, any amount can be given to you. Suppose I'm saying that 20 gram NaOH is dissolved in 400 ml water. Okay. 20 gram NaOH is dissolved in 400 ml water. Find the mass by volume percentage. Okay. So simply the mass of solute is 20. Volume of water is 400 multiplied by 100. So simply divided by like this, and the 4 divided by 20, that is 5%. Answer came over here is 5%. So to tell you the real use of these formulas, what are their use? We have to understand one thing. Suppose in a question it is said that 15% mass by mass solution. If they are saying 50% mass by mass solution, or it can be said as 15% by mass solution, what does that mean? Because in the question this language is given. They will not say this gram of the solute is dissolved in this much amount of the solvent and you have to find out the percentage, or they can say that the percentage is given, you have to find out that how much solute is present, how much solvent is present. Yes, you will have to find out these information, but these information further be used in the next question, or I say in the next part of the question. So please try to understand this language. This is a very, very important thing. 15% mass by mass solution. What piece of information we are gathering from this statement? 15% mass by mass. It It means there is 15 gram solute in 100 gram solution. It means we got weight of solute 15 gram, weight of solution is equals to 100 gram, then weight of solvent 100 gram minus 15 gram, and the answer is 85 gram. This much information can be gathered from this statement or this statement, 15% by mass. It can also be said like that, if they would have said 20% by volume, or they could say 20% mass by volume solution. 20% mass by volume solution. It means it is saying 20 gram solute in 100 ml solution. Okay. So this is the importance of this percentage composition, because in the upcoming part of the chapter there will be a several numerical in which only the percentage just like given, and you have to find out what is the weight of the solute or what is the weight of the solvent, because these value will be required in further numerical problems. So we will see the next part of the concentration, that is the mole based concentration. Now, as I told you about the mole based concentration, so first we are going to discuss about term molarity. What is molarity? Molarity is defined as amount of solute, or we can say that number of moles of solute present in 1 liter solution. Number of moles of solute present in 1 liter. Present in 1 liter of solution. इस सेंटेंस को हमें ध्यान रखना है। 1 लीटर सॉल्यूशन में प्रेजेंट सॉल्यूट के मोल्स को ही उसकी मोलैरिटी कहते हैं। तो बेसिकली मोलैरिटी की यूनिट क्या हो जाएगी? मोल्स पर लीटर, or we can say mole liter inverse, that's the unit. Molarity is denoted by capital letter M. So M is equal to number of moles of solute over volume of solution in liter. Number of moles is denoted by small letter n. So n upon v in liters, that is molarity. If the volume is not given in the liter, it is given in terms of milliliter, what we will do? Yes, number of moles, volume in milliliter. If we divide milliliter by 1000, it will turn to liter. If we divide it by 1000, eventually it will reach over here. So we get molarity like this. This is a one very simple formula of the molarity. And we know that number of moles, that is small n, it can be find out weight of solute over molecular weight of solute, WB, weight in grams, and that is molecular weight or atomic weight. If we are taking a single element, we will choose atomic weight here. If we are taking a molecule, that will be molecular weight. For an example, I said that I have 20 grams sodium hydroxide, that is 20 gram NH. Number of moles are question mark, means 20 gram is the weight that is given, WB. So WB here is 20 gram, and molecular weight of sodium hydroxide, that is 23 plus 16 plus 1 atomic weights of the elements, and the sum becomes 40. So number of moles, N is equals to what? WB upon MB. Okay, so 20 divided by 40, we got 0.5 moles, and that is the answer. Okay, so here in place of N, we can also write that molarity is equals to WB upon MB into volume multiplied by 1000, and the unit I just told you, that is mole per liter. And further formula can be written in terms of weight, that can be written as WB is equals to molarity into molecular weight into volume upon 1000, mV over 1000. So these are the formulas of the molarity. Okay, here we have to remember how to find out the number of moles and how to deal with the molarity. Now we shall discuss about term molarity. Molality, okay, that is denoted by letter small m. Molarity was being denoted by capital M, molarity is denoted by small m. Molarity refers to number of moles of solute present in 1 kilogram of solvent. In terms of molarity, we are taking 1 liter of solution. Here we are talking about 1 kilogram of solvent. So this is a difference between the molarity and molality. You must be surprising, we were knowing about the molarity. Why we are going with the molality? I am telling you one major difference between the molarity and molality. Since molality is weight dependent, where the molarity is volume dependent, so as the temperature is changed, the volume will also change, and henceforth molarity will also change. So the molarity is temperature dependent, but molality is temperature independent. It means molality has no effect of temperature. So molality is small m, number of mole, as I told you, is small m, and now weight of solvent. You must be surprising why I chosen WAWB, because I refer that A means solvent and B means it is always solute. So wherever any value or any letter is having suffix A, it means it is from the solvent portion, and where it is having letter B, it is having solute portion. So WA means weight of solvent, that is in kilogram. Okay, if it is not given in the kilogram, it is given in the gram. In that case, WA in gram divide by 1000, so 1000 will come over here as multiplication. Okay, molarity again can be written as, because we know that number of moles weight of solute over molecular weight of solute. Okay, that is weight of solute, and that is molecular weight of solute. Okay. So now we'll have formula. Molarity is equals to WB upon MV into WA multiplied by 1000. That is the formula of molality, and the unit is mole into kilogram inverse. It means mole per kilogram, that is the unit. Or we can also write the formula in terms of weight. That can be weight of solute can be given as molality into molecular weight into weight of solvent, that is WA, upon 1000. So that is M and W over 1000. That was M MV over 1000. Okay. In the case of molarity, it was M MV over 1000, and that was M and W over 1000. So this was the term molarity and molality. Now we will discuss about the mole fraction in the next lecture and some of the uses of these concentrations in numerical problems. Thank you.